welcome to the Lagos State Intervention e-learning program for SS3 students on account of the coronavirus saga. I am Adejobi Monininola Ajibike. I am your chemistry teacher for the day, and we're going to be considering metals as a topic. Why have I chosen this topic? I have discovered that a lot of schools may not necessarily get to this topic before the exam. And secondly, when students get into the exam hall and they find questions on metals, they feel we didn't do this in class. And so a lot of them neglect those questions. But very easy set of questions to answer, because most of the questions that are going to be asked under metals in your exams are things you can readily find around you, right even inside your exam hall. So let's start with some of those things about metals that you basically find in the exam hall that could bail you out. And that's the segment I have tagged metals in daily life. The girls amongst you will readily identify with earrings like I'm wearing, your metallic necklace like I'm wearing, your mother wears wedding ring, and then a lot of you wear wristwatches that have metallic straps. Look around the room where you are going to find frames of doors made of metals, handle of doors made from metals, and possibly maybe you're wearing a pair of spectacles that has metallic handles. Maybe you have ornaments in the sitting room or wherever you are that are made of metals. Quickly look at your mother's kitchen. A lot of the utensils there are made from metals, the commonest of which is aluminum and steel. So there's really no reason why you should get into the exam hall, find questions under metals, and not answer them. So that suffices for metals in our daily life. Now, let's begin to pick a few questions you may possibly meet. A question goes thus: classify metals according to their location in the periodic table or according to their physical states. Right on this board, I have a small version of a periodic table, and that's what I'm going to be using. So let's look at the first classification based on location in the periodic table. Please look closely. You have two vertical columns painted pink here. The first one is what we call the group 1 elements, and those are the alkali metals. The first element on that column is lithium, followed by sodium. And then the second vertical column, group 2 elements, we'll call them the alkaline earth metals. Both groups 1 and 2 in chemistry, we refer to them as the S block elements in the periodic table. You may also find a few of your alkaline earth metals in group 3. You can see some pinkish stuff on this side of the periodic table. But most of the time for your level, we will focus on the ones you can find in group 2. Now, between group 2 and group 3 of your periodic table, there is a mass of elements painted orange in this periodic table. Those are the metals we call the first transition metals. An example that you see commonly around you is copper, zinc, and iron. We call these first transition elements the D block elements. Why? Because they are valence electrons. By that I mean the electrons in the outermost shell of the elements is in the d orbital. Quickly, let me refer back to the alkaline metals and the alkaline earth metals. I did say that we call them the S block elements because their valence electrons can be found in the s orbital. Now, the fourth group under this classification, we've talked about alkaline metals, we've talked about alkaline earth metals, we've talked about first transition metals. Now let's look at the last in that classification, the inner transition metals. These constitute the two horizontal rows at the base of your periodic table. And there are basically two types of them, the lanthanides and the actinides. You can see in this periodic table, they are painted blue. Again, this set of elements are called the F block elements, simply because their valence electrons can be found in the F orbital. Once you have done that, you have answered that question. Let's look at another one. The second classification now, based on their physical states. There are three principal physical states in which a substance can exist: as a solid, as a liquid, or as a gas. Please note, there is no element that exists naturally, there is no metal, rather, that exists naturally as a gas. So your metals can either be solids or liquids. But the good news is here, very easy for you. The only liquid metal that we have is mercury. And that is the silvery substance you can find in your thermometer. If you have ever used a thermometer before, at the base of your thermometer, there is a silvery liquid metal in the glass. That silvery liquid metal is mercury, and that is what rises in your thermometer once that substance is heated. Remember, mercury is the only liquid metal, at least that man has discovered so far. So every other metal, whether the alkaline earth metals, the alkali metals, the first transition metals, and the inner transition metals, the rest of them are what? Solids. Simple. You have answered that question. Now let's quickly look at another common question that comes up in your WAEC or NECO or even UTME exams that a lot of students neglect. State 5 physical properties of metals. Very, very easy. Sometimes the answer to these questions you will see in whatever your supervisor or your invigilator is wearing on that day. If your supervisor is wearing a wedding ring, you know that wedding ring shines or glitters. So the first physical property of metals is the fact that they are lustrous. That is, they shine or they glitter. The second one, quickly think about your mother's kitchen. Metals are good conductors of heat and electricity. And that is why a lot of pots are made of stainless steel, and your electric kettles and what have you. Even your electric iron is a metallic substance most of the time. It's only the handle that you find that is plastic material. So the next property of metals that should readily come to your mind, because metals are good conductors of heat and electricity, they of a necessity must have high melting point and boiling point. Otherwise, your mother's pots must have melted over the years. Now, the next property of metals, metals have high tensile strength. That is, they can withstand a lot of stress. That is why metals are used for heavy-duty jobs. Again, that is why your mother uses metallic substances as pots, because they can withstand stress. In fact, a lot of times, your mother will tell you, I have been using these pots for the past 20 years, even before you have been born, because that metallic substance can withstand a lot of stress. The next property, metals are malleable. That means they can be beaten to give various shapes. Look around you wherever you are now. You will find a lot of metallic objects having various shapes and sizes. That talks about the malleability of metals. And the last physical property that I will treat concerning metals is the fact that metals are ductile. That means they can be drawn into thin wires. Look around you again. All the electric cables you can find. If you peel off the insulator, you are going to find thin wires. That talks about ductility of metals. Quickly, let me treat another question before we take a short break. Another question. Summarize the reaction of metals with water. An average chemistry student thinks, how do I look at all these classes of metals, rather, and then summarize their reaction with water? It's simple. You can classify all these metals as either very reactive, moderately reactive, or non-reactive. The very reactive metals, one, if you can't remember any metallic substance that is very reactive, please remember sodium. Because sodium is one metal you find in daily life. It's a major component of your table salt, sodium chloride. It is a very reactive metal. In fact, it is so reactive that sodium has to be stored under liquid paraffin so that it does not come in contact with water or moisture. Otherwise, you have an explosion in your hands. So, the very reactive metals, sodium, a typical example, reacts with cold water because they are very reactive. Once it comes in contact with sodium, with water rather, you have an explosion. And then what you get is the corresponding alkali. In the case of sodium, you get sodium hydroxide and you get hydrogen gas. Another reactive metal is calcium or potassium. All of them, when they react with cold water, will give you the corresponding hydroxides and hydrogen gas. So that deals with the reaction of metals with cold water. Now let's look at the moderately reactive metals. Example, magnesium, aluminum, zinc, and iron. These moderately reactive metals will not react with cold water. They will only react with steam. That is water in the gaseous state. And when they do, they give the corresponding oxides of the metal. And again, hydrogen gas is produced. I am sure you are very familiar with the concept of rust or rusting of iron. Anytime you find a piece of iron that has turned into rust, it is simply the fact that iron has reacted with steam and oxygen, and then it has produced the rust. And then obviously hydrogen gas will be produced. Now, the last class of metals, rather, the least reactive or the non-reactive metals. Please readily remember gold as a non-reactive metal. It neither reacts with cold water nor steam. That's why your mother's wedding ring will last until she dies and even thereafter, because gold is a non-reactive metal. It will not react with cold water, neither will it react with steam. We will draw the curtain for a while here, and then we'll come back to treat some other questions. Please, when you get into the exam hall, don't move away from the questions on metals. The answers you can readily find around you. Thank you very much. Okay, welcome back once again. Now, the question we're going to treat has to do with compounds of metals and their uses. And I'm going to focus on the ones you can readily find around you once again. The first one, a lot of you use toothpaste. Calcium fluoride is a compound of metals found in toothpaste. At the same time, sodium fluoride, the two of them are components of your toothpaste that help to fight tooth decay. Sodium chloride, again, is another compound of a metal used in food preservation, food seasoning, and glazing of pottery. Sodium hydroxide, another compound of a metal you can relate with, is one of the alkalis we use in titration. It is used in the production of laundry soap. Now we go to sodium trioxocarbonate 4. That one is used to soften hard water. Rainwater is a typical example of hard water. Sodium trioxocarbonate 4 can be used to soften it. And of course, a lot of you eat a lot of confectionaries, cakes, and biscuits. Sodium hydrogen trioxocarbonate 4 is the component of your baking powder. We all eat food. Sodium trioxonitrate 5 is used to produce nitrogenous fertilizers, which help to boost crop production. This one will interest the girls. The last one I want to treat, zinc oxide, is a major component of your face powder. Ointments used to produce, substances used to produce ointments that treat skin infections and diseases. And at the same time, is a component of body creams, lotions, and medical ointments. Please, let me take this also. Zinc tetraoxosulfate 6 is used as a dietary supplement and is a vital substance in the production of sex hormones in men. I want to believe you have been able to pick a few things from what we have treated. Now let's talk about another compound of metals that is very useful. Calcium hydroxide is used to neutralize soil acidity and at the same time to test for carbon 4 oxide in the laboratory. Thank you very much.